This chapter is going to cause us to think a little bit more abstractly. We've been exposed to many of the practices and concepts surrounding object-oriented programming, but we haven't really quite got to the heart of object orientation. The primary motive behind object-oriented programming is reuse. That is reuse. We create classes that can be turned into objects for other programmers to use. And as we've come to learn, objects have properties and methods. We've seen properties and methods with some of the objects we've used, such as the string object. So, object-oriented programming involves programming using objects. And an object is simply a representation of an entity in the real world, something that can be distinctly identified. For example, a student, desks, a circle, a button, even a loan can be viewed as an object. Now, objects have unique identity. They also have state, which we call properties, and they have behaviors, which we call methods. So the state of an object consists of the set of the data fields with their current values. And the behavior of an object is defined by the set of methods that are defined as part of the object's class. As the slide depicts, objects are derived or instantiated from classes. And a class is simply a template. Note that objects derived from the class circle have a unique identity and the different values for the radius. Think of a class as a cookie cutter. And just as the cookie cutter is not the cookie, a class is not the object. Each cookie we make is a little different from every other cookie. One has red sprinkles, another has blue sprinkles, one may have frosting, etc. And just as in objects that we create or construct from a class, they are distinctly different. They're different based on the values given to their properties. So circle object 1 is different than circle object 2 and is different from circle object 3. Oh boy, this looks confusing. Well, a Java class is much like a program, but it's not a program. I repeat, a class is not a program. A class is not executable by itself. But a class has variables to define its data fields or properties, and methods that define its behaviors. So additionally, classes provide some special methods known as constructors. We use these constructors to construct or to create objects from the class. One of the hallmarks of object-oriented programming is that classes only expose or access to the object through public methods. The implementation details of the class or object are hidden from the programmer using the object. And the class contains the definitions of all the properties and methods needed. So, two objectives in defining classes, okay, are information hiding and encapsulation. That is, everything we need is defined in the class. Hiding is accomplished using the private accessor modifier. So we see in our class definition up there that the radius property is hidden using the private accessor. Now, the public accessor exposes methods to the programmer for use. And if no accessor is specified, public is the default. So the only way a programmer can change the radius in our class here, or find the area of a circle, is through the methods exposed for his and her use. Seems like a lot of work and kind of silly. Why don't I just have a variable as part of my main method and set its value to a radius? And if I want to compute the area, that's easy enough. Well, what will you use for the value of pi? Math.pi? Maybe somebody else will use 3.14. And maybe another programmer will use 3.142, etc. And if we all use the circle class to construct our circle, we'll be guaranteed that the circle will always compute, the circle with the same radius will always compute to the same area. So how do we use this circle class we've created? Well, now I've got two variables, each representing a different circle. Yes, I have two objects, and they are unique. The variable my circle and the variable your circle are reference variables, and they point to the objects somewhere in memory. Now, once we've constructed our objects, we can use them. In this case, we're using the system.out to report the area of my circle and your circle. And note that familiar dot notation that we've used in the past. Well, UML stands for the Unified Modeling Language, and it is used at design time to model our classes, right? And our diagram is called a class diagram. Now, by convention, we've learned that class names begin with a capital. And organizationally, our diagram then identifies the properties of the class and their data type. And note that we use a horizontal line to separate the different parts of the diagram, the name from the properties and the properties from the methods. All right? So after the properties, we define the methods. And usually, by convention, constructor methods are defined first. We need these methods to create new objects of the class type. A Java constructor is always named using the class name. And notice in the diagram above, we have overloaded constructors. Remember, overloaded methods are methods with the same name, but different signatures. In the case of our circle class, one constructor expects no input, and another constructor expects a double. Java sorts these things out. All right? Constructors are followed then by methods that generally are referred to as getters and setters. These are methods that we use to setters, the value of properties after our object has been created. And getters are used to return the value of our properties. So these are methods, right? And by convention, the names of these methods generally start with set and get. Following the getters and the setters would be some other methods we might need, right? Such as report area. Now, the UML for the objects, as shown, those are used at design time for a program that will use this class, and in this case, the circle class. So what is sometimes hard to get your head around is that a class is not a program. By itself, it is not executable. Note, it has no main. Remember, a class is not a program. It needs a program to use it to be of any meaning. So we need a program to instantiate or create objects of our class. And the object that we instantiate is a reference variable. And once the object is instantiated or created, then the programmer has full access to the methods, to the public methods of the object. And it's the public methods that define the behavior of the objects that we create. Well, let's take a look at a class, right? The only thing different here from what you've been doing is we don't have a main. We have variables, our properties, and we have methods. Lines 2 through 4 declare and initialize our properties. Lines 9 through 13 turn our TV on or off. Really, all they're doing is setting the value of variables of our class. And note that the methods in line 17 and 22 are the setters. They expect some input from the calling program, and they set the appropriate properties to the value that is passed to them from the calling program. Oh, I ignored line 6 up there, our constructor. And our constructor is just an empty constructor. It doesn't do anything special. Oh, lines 22 or 27, 32, 37, 42 are some more methods. We change the channel by increasing the channel or turning it up or down, or the volume up and down. So note that all the methods, from line 17 on, check to be sure that the TV is turned on before it tries to change the volume. And even when we try to set the channel, it assures that we're not setting the channel beyond a given range. Now, note that in this simple class, for example purposes, it has no getters. That's because the properties, channel, volume level, and on, are public. Now, this is really considered bad programming. Since the properties are public, then the calling program can access them directly rather than requiring the calling program to access them through a method. Well, whenever you create a class, it's incumbent upon you to test that class and all the methods. So you write a little program. We call it a tester program. In our little tester program here, you notice that lines 3 and lines 8 instantiate a new TV object, and lines 4, 5, and 6, and 9 through 12 exercise various methods of the object. And finally, lines 14 and 16, where we do the system.out, are accessing directly the object's properties. So we've pretty much tested our class, and now we can turn it over to programmers that need to use a TV object in their program. They have no reason to test the object. We've tested all the methods. They all perform correctly, and so forth. The constructor methods, they deserve a little special attention because they're a special kind of method, and these are the methods that are invoked when we instantiate or create an object. So a constructor with no parameters, such as the first constructor on the slide, is referred to as a no-arg constructor. No-brainer, right? Constructors must always have the same name as the class, including the capitalization. Constructors never have a return type, not even void. So that way they're a special method, because we've learned that methods need to have a return type. And constructors are invoked or called from a using program with the new operator. And that's when an object is instantiated. And so usually what constructors do is they play the role of initializing the value of the properties of an object. Now, do you have to have constructors when you write a class or create a class? No. A class may be declared or developed without a constructor. However, in this case, a no-arg constructor is implicitly created for you. And this constructor is called the default constructor. It's only provided, however, if there are no constructors explicitly declared in your class. Well, I've been using the term construct or create, but the proper term is instantiate. And note, we instantiate a variable of the data type that the class represents. In this case, circle. The example shows us using two different constructors. The first constructor uses the no-arg constructor, and the second one uses the constructor that is expecting a double to be passed to it. Point to remember is that my circle and your circle are reference variables. They point to some place in memory where the objects and their properties exist. Well, that was a really short introduction to objects and constructors and classes. Now would be a good time to get your questions ready for class. You want to prepare those questions especially because we're not done with classes and objects yet.